Hello everyone. Today we are going to start by chapter 1 in physics, talking about making measurements. It has 3 sections. Section 1 is talking about measuring length in volume. Section 2 is talking about density, and the last one, measuring time. So let's start in this video by measuring length in volume. Length, to measure the length, we have different tools. For example, if the length was between 1 millimeter and 1 meter, so it's preferable to use the ruler. And if it was less than 1 millimeter, so we can use something called micrometer screw gauge. And if it was more than 1 meter, so you can use a measuring tape. How to use the ruler and make a reliable measurement using the ruler? Reliable means you can depend on them, so it's accurate. First, if you are measuring this wire, for example, it should be straight wire alongside the ruler. It should be straight, not bending or not curling up or down. So it should be straight along the ruler in order to have an accurate measurement. Number 2, it should be cut neatly. Some of the wires are not cut neatly, so you don't have a definite end for the wire. So it should be cut neatly so that you can have an accurate measurement of the wire end. Number 3, start at 0. You have to start the object you are measuring its length from 0. And markings of the ruler, make sure that the markings of the ruler are equally spaced. Equally spaced means they are having the same space for each 1 millimeter. Number 4, read the scale at the end and repeat your reading. So here I will take the reading. The length of this wire, for example, is 3 centimeters. I have to take the reading many times because sometimes it's part of centimeter. So you have to be accurate in taking the measurement. By repeating the reading many times, you will have more accurate results. We have some key words in this part. First one is the standard. Standard is an absolute or primary reference or measurement. For example, how do we know that this is a meter? We are all using the same length for the meter, and we are comparing it to something called standard. So we have a standard for the meter that we all compare our meter to this standard. Number 2, precise. Precise means what? When several readings are close together when measuring the same value. For example, I have measured the length of this wire many times and I found the same result, which is 3 centimeters. So this means that my results are precise or accurate. Then, calibrated. Calibrated should agree closely with a standard or agree when a correction is applied. For example, this ruler is calibrated. This means that I have compared the centimeters in meters on this ruler to the standard value and I found that it's calibrated. Also, if I'm using, for example, a balance, calibrated means what? Means that the 0 reading, when there is no reading, when there is no mass on this balance, so it gives a 0. Okay, so this means the balance is calibrated. Calibrated means it starts at 0 when there is no reading. And also, the spacing between each 1 kilogram and the other are equally displaced. And also, they are equivalent to really 1 kilogram. This is the meaning of calibrated. We have some measurement techniques that are different than the ruler or measuring tape. So, for example, if I need to measure the thickness of a sheet of paper, it's hard to measure the thickness of a sheet of paper using the ruler. So, in this case, you have to select, for example, 500 sheets of paper and then measure the thickness of these 500 sheets of paper, then divide your measurement by 500. In this way, you will find the thickness of one sheet. If I take just 20 sheets, okay, for sure I will get an answer, an average thickness of the sheet, but it won't be more accurate than 500. So 500 is more accurate. If you take a larger number, it will be more accurate than a smaller number. Length of curved line. If I have, for example, a curved line like this, or a circumference of a cylinder, so how can I measure the circumference or the curved line? I will use a thread alongside the line like this. Then I will mark the thread at the end, okay, at this end and the other end, and then I will align it on the side of a ruler and take its length. In this way, I will find the length of this curved line or circumference of a circle or any curved circle. Third technique is thickness of a wire. Thickness of a wire is having two options to measure. Option number one, using the micrometer screw gauge that looks like this, I will put the wire inside and have the readings through two scales here. Then, option two, I will measure the thickness of number of turns, then divided by the number of turns. Exactly like the idea of measuring thickness of stack of papers. So here I will roll or coil the wire around any stick like this, okay? Then I will put it beside a ruler, take the number of turns and count the number of turns and count their length, then divide the length I found by the number of turns I have, then I will have the thickness of each turn, which is the thickness of the wire itself. Those are different techniques for different scenarios used for measuring the length. Let's move to measuring volume. Measuring volume, we have three scenarios for measuring volume. Volume first is the space occupied by an object. How much space is occupied by this object? I have three scenarios for measuring the volume. The first one, if the shape is regular. Regular means, for example, cube, cuboid, sphere, cylinder, or cone. So this means it's a regular shape. So in this case, you have to take one or two measurements, then substitute in the equation of the volume. For the cube, the volume is the side to the power of 3, cubic side. And for the cuboid, length times width times height. For the sphere, it's 4 over 3 by r to the power of 3. And for the cylinder, it's by r square times h. It means area of base times height. And for the cone, 1 over 3 by r squared times h, the same as the cylinder, but multiplied by third. This is the first thing, if the shape was regular. So you will take the dimensions of this shape and substitute in the volume equation. Number two, if it was a liquid, how to measure its volume. So in this case, you have to use the measuring cylinder. But you have to care about two things. Look at the scale horizontally and not an oblique angle. For example, here, if your eye is here, then you are going to look at this level. Some questions are asking you to draw the horizontal line or the line that shows the angle of the angle that you will look at the measuring cylinder at. So you will look, you make an eye like this and put a horizontal line. You have to draw it horizontally. Don't point like this, don't point like this. It should be horizontal line like this. Number two, read the level of the bottom of the meniscus. What is a meniscus? We will find that the surface, the upper surface of any liquid is whether curving down or curving up. Okay, in case of water, that's usually used is it's curving down. For example, curving up like the mercury, for example, but we are not using mercury in our measuring cylinders for measuring the volume. We are using water, so it will be curving downward. So this surface, curving surface, is called meniscus. So it's the curved upper surface of a liquid. Okay, which place should I take the reading? This, for example, the sides will give a higher reading than the bottom. I should read the bottom of the meniscus, this in the center. So read the level of the bottom of the meniscus. Okay, then what else? Third thing I have to care about, choose the cylinder size carefully. For example, if I'm just using a very thin cylinder, okay, for measuring a huge amount of water, it will flow over. For the overflow. For example, if I'm having a very small amount of water like this, it won't show an accurate reading on this cylinder. So you have to measure, to use a a cylinder that's suitable in size to the amount of water or liquid I'm measuring. Okay. Number 3, if the shape was irregular shape, like a stone or anything like this, you will use a way of measuring volume called displacement. So you will measure the volume by displacement. What's displacement? First, you will select a cylinder, okay, about 3 to 4 times larger than the object that you have to insert inside. For sure, you have to choose a suitable size for the cylinder. Number 2, partially fill it with water. Don't fill it to the maximum because you are going to insert this object inside after that. So, or else the water will overflow. So you have to partially fill it with water, but this water also should be enough to fully cover the object that will be inserted inside. Number 3, immerse the object in water. Immerse, it means totally covered with water. Okay? What will happen if we immerse the object in water? For sure, the water level will rise up because the stone or the irregular shaped object is displacing the water, so it will be pushed upward inside the cylinder. Then the increase in the volume is the object volume. I have put the water first without anything inside the cylinder except for the water. So I will record this volume first. This is V1. Okay? This is the volume of water only. Then after inserting the object, I will have another reading for the volume. This is the volume of water plus volume of object. So this is V2. I will record it too. The difference between the two volumes is the volume of the inserted object inside the cylinder. Okay, we have one more idea in a question talking about a floating object, for example, wood, that it floats. Whenever I put it in the measuring cylinder, it floats upwards, so it couldn't be immersed in the measuring cylinder. What should I make in this case? I will use a steel block to immerse the wood in water. How can I make it? First, in the first step, I'll bring the water with the steel block inside. Then I will record volume 1. In the second case, I will put the piece of wood and put the piece of steel upward to make the wood sink. Then, and I will note that the water level will rise up. So I will record volume 2. In the first case, it's the volume of water plus steel. In the second case, water plus steel plus wood. So the difference between the two volumes is the volume of wood. Okay? In this case, I'm calculating the volume of the floating object inside a measuring cylinder. We have some keywords here, which is displace and immerse. Displace means moving something to another place. So water is moved out of the way upward when an object is lowered into it. So this means when you are going to put a stone inside or anything inside the water, it will displace the water and move it upward in the measuring tube. Immerse means to cover something in a fluid, usually water, so that object is submerged, totally covered. Units of mass and volume. Sorry, unit of length and volume. Okay, the SI units of length and volume. The SI means the International System of Units. For making a comparison between different readings all over the world in any experiment or in any research, so we have to use the same units to easily compare our results. That's why there is an International System of Units. For measuring length, we use meters, and for measuring volume, we use meter cube. But we can have different units for length and for volume. Like, for example, 1 decimeter is 0.1 meter. 1 centimeter is 0.01 meter. And 1 millimeter is 0.001 meter. And micro, it's dividing by 10 to the power of 6. And 1 kilo multiplying by 1,000. And for the volume, 1 centimeter cube, which is the same as 1 milliliter, it's equal to 0.000001 meter cube, and 1 decimeter cube is equal to 0.001 meter cube, which is 1 liter. How can I convert between different units? First, we have to know that if I'm changing from the big unit to the small unit, I have to multiply. And if the inverse, I'm changing from small unit to big unit, I have to divide. Then, second step, I have to know what are the prefixes used in physics. For example, the centimeter means what, the kilometer means what, and so on. So here, again, if I'm changing from the big unit to the small unit, I have to multiply. If I'm moving backward, I have to divide. For example, here, to move from kilometers to meters, I'll multiply. Also from meter to centimeter, I'll multiply. From centimeter to millimeter, I'll multiply. Kilo means what? Kilometer means times 1,000. Kilo followers, 1,000 followers. Okay, meter to centimeter. I'll multiply also because I'm moving from the big unit to the small unit. Centi means 100, so times 100. From centimeter to millimeter, I'll multiply also by 10. If I'm moving backward, I have to divide by the same numbers. For example, if I have 5 kilometers equals watt meters, now I have to move from the big unit to the small unit. So I will multiply. Multiply by what? If I have kilo, this means multiply by 1,000. So 5,000 meters. Then second one, 120 centimeters to equals to watt meters. So moving from the small unit to the big unit, now I have to divide. Centi means 100, so divide by 100. Divide this by 100, it will give 1.2 meters. The same in volume. If I'm moving from kilometer cube to meter cube, look at this number from kilometer to meter, I was multiplying by 1,000. Here, I'll multiply by 1,000 cube, since it's kilometer cube, meter cube, also 1,000 cube. The same numbers, but they are all cubed. Here, from meter cube to centimeter cube, I have to multiply by 100 cubes. So think of this to this. How to change meter to centimeter? I multiply by 100. If it's a cube, so 100 cube. And the same backward, I will divide by the same numbers. So let's take this example. If I have 5 kilometer cube equals to watt meter cube, then from kilometer to meter, I have to multiply by 1,000. If it's a cube, so I multiply by 1,000 cube. 1,000 cube means 10 to the power of 3, all to the power of 3. If I have power to the power, I have to multiply the powers, so it will be 10 to the power of 9. So in this case, it will be 5 times 10 to the power of 9 meter cube. Well, if I have here 3 meter cube, I want to change to centimeter cube. Okay, from meter to centimeter, from big to small, I have to multiply. Multiply by what? By 100, because it's a centi. Now I multiply by 100 cube. Okay, so 3 times 100 cube. 100 cube means 3 times 10 to the power of 2, all to the power of 3. Now multiply the powers. 3 times 10 to the power of 6 centimeter cube. Okay, let's move to density, the second part. The second part is talking about density. For knowing the density, we have to discuss first what's mass. The mass is the quantity of matter inside an object. So it doesn't change. It doesn't change moving from one place to another. It doesn't depend on the gravity. The object, it causes the object to resist changes in its motion. For example, if I have a heavy object, I couldn't change its motion or couldn't change its motion easily. I couldn't move it easily. I couldn't change its direction easily. If it was light, I could change it easily. Also, it causes it to have a gravitational attraction for other objects. For example, the Earth is so massive, so it has gravitational attraction for objects on it. And we will take this later in Newton's gravitational law. And for the density, to understand what's the density, let's look at this drawing. For example, this is high dense because all the particles are filling the space. Okay, so it's more concentrated mass. But here, the mass is not concentrated in the same volume, it's not concentrated. So this is less dense. So the density is the ratio of mass to volume of a substance, or how concentrated its mass, or mass per unit volume. We can say it in different ways. So to calculate the density, we will divide mass by volume. Density has a simple rho. Okay, rho equals mass over volume. The mass is measured in kilograms, volume is measured in meter cube. So this means that the rho has a unit of kilogram per meter cube. Okay, and we can draw a triangle for it, m rho v. If you want to find v, so it's m over rho. If you want rho, m over v. If you want m, rho times v. Then, what about if it's vector or scalar? As we said, to determine if it's vector or scalar, let's imagine that the scalar is positive and vector is negative. Mass is a scalar, so it's positive. Over volume is a scalar also, so it's positive. Scalar means it doesn't have a direction. Vector having a direction. So positive divided positive gives a positive. This means that the result is also scalar because it's positive, so it's a scalar. For sure, I'm not talking about the scalar to be always positive or negative for the vectors, but it's a way, a tricky way to use to determine whether the result is scalar or vector. We can have other units for density like kilogram per meter cube or kilogram per decimeter cube or gram per centimeter cube. It's okay depending on the givens. Density of water, it's useful to know its value. If it's in kilogram per meter cube, which is the SI unit, it will be thousands. If it's a kilogram per decimeter cube, it will be 1. Also gram per centimeter cube, it will be 1. Gases are having much lower densities than solids and liquids. And this is very logic because the particles in gases are spread everywhere. They are not concentrated in the volume. So they are less dense. If an object is having less density than water, this means it will float. If it's more dense than water, so it will sink. Okay? So for example, the oil is less dense than water. That's why it floats. So any question about why this object floats over water? Because it's less dense than water. Why this object sinks in water? For example, the steel block, because it's more dense than water, and so on. If I have this example about a sample of ethanol has a volume of 240 centimeter cube, its mass is found to be 190 grams. So what's its density? I have the mass here, 190 grams. I have the volume, 240 centimeter cube. So to find rho from here equals mass over volume. So rho equals 190 over 240 centimeter cube equals 0.79. And don't forget to write the units here. The units are given in grams and centimeter cube. So the density would be gram per centimeter cube. Okay, let's take the steps of measuring density in the lab or in a practical way. First, you have to measure the mass. We use a balance to measure the mass, okay, and record the mass. Then find the volume of the object with one of the ways we have mentioned before. If it's regular shape, irregular shape, or it's a liquid, or something that floats, then record the volume and calculate rho using the equation rho equals mass over volume. But if it's a density of a liquid, it has some different procedures. Place the measuring cylinder on a balance. First, I have to put the measuring cylinder empty on a balance. Then, set the balance to 0. Put the balance at 0. Okay? Then pour the liquid into the cylinder. Second, I will pour the liquid inside. Okay? Read the volume from the scale. I will take the volume from here and mass from the balance. And now I have the volume and I have the mass. I will divide mass by volume to find rho. This node is about the different solutions or different liquids if they are having different densities, and we put them all in one container. They will arrange themselves such that the lower one will be having a higher density and the upper one that are less density or less dense, making something that we call liquid density tower. It will be more obvious or easily to be seen when they are having different colors. Okay, in this case they are not mixing. This is called immiscible. Immiscible means when a distinct layer forms in a mixed solution, there is a distinct layer. But when they mix, for example, any solutions that are mixing together, this means that they are usually dissolving each other. And last part of this chapter talking about measuring time. We have two types or three types of measuring techniques. First, the analog. The analog is a display has hands or needle, and it's not precise that much because it's taking to the nearest seconds. But the digital one, it shows numbers, like the stopwatch or digital clock, it shows numbers and it's often more precise because it takes hundreds of seconds. And we have another technique that's a light gate connected to an electronic timer. And we said this is very useful to measure the rapidly moving objects to move between 2 points. Like racers, for example, you should be more accurate because they are running so fast. And the difference between the two players is so small. So we have to use something more accurate than the digital clock because it may take time in stopping and playing it. Then we will talk about the lab pendulum. The pendulum is a plumb bob hang on the end of a string. The string is also clamped tightly at the top by two wooden uh, um, jaws here. It's hung from this, and here a string that's hanging a bob at the end. The plumb bob, a mass, usually lead, made of lead, downward straight, hanging from a string to define a vertical line. It defines a vertical line downward. The time of one oscillation of a pendulum is called period. What does it mean, one oscillation? For example, the pendulum is here, and this is the bob. It moves first to this position. This is the highest position ever. And then to the next side, to the second side at the same height, but on the other side. So let's imagine it starts from here, then it will move upward, then go backward here. This is not one oscillation because it's not completing its oscillation yet. It should move to the other side. And now also it didn't complete one oscillation. It should return back to the starting point. So one oscillation means reaching the starting point after completing a whole cycle because it reaches it twice. Look, it reached after half a cycle, it reached the starting point, but it didn't complete the cycle yet. It will go to the other side and go back to the starting point. Now it has completed one oscillation or period. The time taken for making this oscillation is called period. Oscillation means what? Repetitive motion or vibration. This is one oscillation, okay? Because it's repeated all the time in the same way. Period is the time for this oscillation, the time taken for one complete cycle or oscillation, or one wave. The time it takes an object to return to its original position, but after finishing the complete cycle. To find the amount of time it takes, it's very short time for making one complete oscillation. This takes very short time. So if we want to count the time taken for one oscillation using a stopwatch, the stopping time in playing time will affect the reading of my oscillation. I couldn't count one oscillation accurately. So in this case, I have to count the time for about 20 to 50 oscillations and calculate the average time per oscillation. So for example, if I got the time for 20 oscillations, I got 200 seconds. So I will divide it by 20, the number of oscillations, I will get 10 seconds. So it takes 10 seconds for one, for example, for one oscillation. If I take large numbers like 50 oscillations, it will be better than 20 oscillations. Why? Because the stopping time, the inaccuracy in the stopping time, okay, will be less if large number of oscillations are taken. Because, for example, if I was delayed by 0.01 seconds, okay, in the stopping and the starting time, I have an error of 0.01. 0.01, if it's divided by 20, okay, it will give a small number, but if it's divided by 50 oscillations, it will be very, very small, and we couldn't even notice the inaccuracy in measurement. This is a very important note. It was in one of the questions of the past papers. To measure the center of the pendulum bob accurately, for example, this is the bob hung from a string, and I want to measure the center of the bob accurately. So I have to use a horizontal aid. What does it mean? For example, a ruler or a square set to make sure the measurement is horizontal, because I'm measuring from this level to the center of the bob. So I have to use, for example, a ruler or a square set, okay? So as to make sure that this is vertical and this is horizontal. Okay, to make sure that the bob, the string of the bob, is making a 90 degrees with the horizontal level. And also, we have to make something called bob touching rule. This means that we couldn't touch it strongly, or else we are going to move it and change the reading. So we have to touch it gently, okay, to touch the center of the bob. So we can make the measurement accurately without changing it. By this, we come to the end of the chapter, and later on we will discuss some questions related to the chapter. Thank you very much.